And for our fractions, let's make sure we know this. We'll have a couple subheadings here. The first one, but they're all on the fractions, so it'll be good. The parts of a fraction, ladies and gentlemen. If you have the fraction 7/8, what is the top of a fraction called, Brendan Massey?
The numerator?
Yep, the numerator. Just make sure you have that labeled so when I ask you. And the unfair bottom of the fraction, Ephraim? Think Schwarzenegger. I'm the denominator. Numerator top, denominator bottom, and this lovely guy here we just call the fraction line. And it's important to remember, ladies and gentlemen, that a fraction really is nothing more than a glorified division problem.
Yep.
Okay. You're taking something, cutting it into 8 equal parts, and you have 7 of them. Well, it doesn't give you a whole number, but there is something there. So it's just glorified division. Taking 7 things and dividing it into 8, or 7 and dividing it into 8 equal parts. It doesn't give you a whole thing, but it gives you pieces of parts. Now, with that, the little subheading number 2 is, what about word problems? If you have a fraction word problem, somebody tell me what I'm going to say next. Oh, please, you know me better than that. Oh, after all of this, Charles, we have not gone to that extent. For fraction word problems, you are going to, Olivia? Yeah, you'll sketch it out, but specifically what are you going to sketch? Sam? Yeah, you're going to make fraction rectangles. I can call them something, but I can't think of what it is. Fraction boxes? Maybe that's what it is. Or a fraction box. You will find your life is so much better if you do that. And eventually I'll tell you you don't have to because you're smart and old. But so here's the deal. Here's an example problem. There were 30 questions on the test. 30 questions on the test. 1/3 were true and false, and 2/5 were multiple choice. 1/3 true and false. And what did I say, 3/5? 3/5 multiple choice. Multiple choice. Oh, it was 2/5 for multiple choice. Doesn't matter. Can I do 1/3, 2/5? Let's do 2. Let's change that to a 2. That's why you do stuff in pen and soul. So on this one, actually, you're going to probably need to draw a couple boxes because the fractions don't have the same bottom number. So this is how that would look. First of all, you draw a fraction rectangle, and what does it always stand for? It always stands for the total amount you have. This stands for 30. In this case, it would be 30 questions. And you're looking for 1/3 of them. So the bottom number tells you how many equal pieces you're cutting your odds into. If you take 30, cut it into 3 equal pieces, each piece is worth 10. And the top number tells you how many of those pieces you have, which is 1. So I have just 10 true and false. That answers the first question there. 10 true and false. The second question asks you for 2/5. So you can't use this one because I already cut that into 1/3. So I'm going to have to sit and sketch another one real quick. I know this will take you all of about 10 seconds. Still stands for 30. If I want 2/5, Bottom number, I cut it into fifths, 2, 3, 4, 5. If I take 30 and cut it into 5 equal pieces, Kevin, each piece is worth? 30 divided by 5 is? Yes, 6. And I have, the top number tells you how many of those pieces you have. You have 2 of them, so 2 sixes is 12. 12 of them were multiple choice. How many problems would remain that are not true and false or multiple choice? 8. Sam, what type of problems would those be? Just make something up. Short answer? Essay?
Wrong.
What else? What?
Wrong.
Wrong. Yeah, that's you're probably there. And then the last thing the book asks you to do is this. Got down this third example here. Order from least to greatest. And then they'll give you 3 fractions, 3 6, 3 fifths, 3 eighths. 3 6, 3 fifths, 3 eighths. If I'm trying to find the smallest slash next smallest and then the biggest one, first of all, there's a couple ways you can do this. You can change them all to the common denominator, which is what we'll do in the end. But for this one, you don't need to do that. What is the thought process in finding the smallest to the biggest? Oh, please. Tell me that you're just not answering because Brendan Massey?
Isn't it like the smaller the denominator, this?
Not necessarily. You can't go by how big or small these bottom numbers are. I mean, just because this is an 8 doesn't make it the biggest fraction, or that's 5 doesn't make it the smallest fraction. It's not that. It is,
Compared to if it's less than or greater than.
Yeah. Your first thought is to compare to 1/2. How do those fractions compare to 1/2? 3 6, if you say, how does that compare to 1/2? Since the top is exactly half the bottom, this is the same as 1/2. 3 fifths. I think a half of 5. Is 3 bigger than 5 or smaller than 5, Ronnie? It is?
Bigger.
Yeah, so this is larger than 1/2. And 3 eighths, half of 8 is 4, so this one is smaller than 1/2. So you automatically know, since this is smaller than 1/2, it's the smallest fraction. This is equal to 1/2. It's there, and this one is bigger than 1/2. Sometimes that will not work because 2 fraction will end up being bigger than 1/2, and then you got to do some other thing. But for all intents and purposes, for right now in your 7th grade mathematical world, that, ladies and gentlemen, will get you home. How about that? What do you think? How much time do we have?
10 minutes.
Wait.
10, 15.
No, it's 8:50 to 9:40. So we have 13 minutes. Think you could average a problem a minute?
Probably.
2 problems a minute?
Probably, yeah.
3 problems a minute, Rev? 17 problems a minute?
No.
Yeah, let's go 1 through 13.
Thank you.